So now we'll continue with Jim Adamski. He is giving a presentation on tubing maintenance. He comes to us from CDL, Wisconsin and Roth Sugarbush. Go ahead, Jim.
So as part of my job as a sales consultant for CDL, Wisconsin, Roth Sugarbush, I do a tremendous amount of woods evaluation for tubing systems, for both new tubing systems going in, existing tubing systems that are in use. You know, we usually get asked a lot of questions. Okay, how do I improve the performance of my system? What do you see wrong with the system? You know, so I end up in literally hundreds of woodlots throughout the course of the year. We see a lot of really good tubing and we see a lot of poor tubing. And we're just going to run through some things that, regardless of the age of your tubing system, that you can do to kind of increase your performance, increase your yields. So when we start talking about a properly maintained tubing system, you know, the first thing, of course, is it will yield more sap. You know, and that's really what we're looking at for those of you that have invested the money into a tubing system, whether it be gravity, whether it be, you know, high vacuum. We can spend a tremendous amount of money on these systems, and we need to see that return on investment. We need to get that money back out of that system, and that's going to come, of course, in the area of sap yield. You know, some of the other things that these tubing systems will do is, you know, if it's maintained properly, it's definitely going to allow us more time in season to repair the leaks. If we're on vacuum, to get our vacuum level up. If we're just simply on gravity, to make sure that we have no liquid leaks. We will definitely produce better quality sap and better quality syrup. You know, a properly maintained system will definitely increase our sap and syrup quality. The other thing it does is because we're doing a lot of the labor off season, whether it be in the fall or through the early winter months, we have a lot more time in season to process sap and to spend more time, you know, focusing on making a good quality product rather than spending as much time as we would be in the woodlot. So when we talk about main lines, you know, really the first thing we need main lines to do is we need slope. Okay. And we need to remember that gravity moves sap. So when we look at slope here in the Midwest, of course, we are not blessed with a lot of slope in a lot of places. You know, if we all lived in Vermont and made syrup out there, it seems like everything runs downhill to a road out there. Things are pretty simple and straightforward. You know, here in north central Wisconsin and central Wisconsin, we have a lot of woodlots that have a very low amount of slope. So like I had mentioned, you know, we do not have the slope here in the Midwest that they see in the eastern states. So in a lot of cases, you know, we see a lot of consultants that come out from the east, come out to the Midwest, and they'll tell us, hey, you need to have at least 2 to 3% minimum slope on your tubing system to make it work. That'll work very well if you're in Vermont or Maine. You know, here in the Midwest, like I had mentioned, we have a very limited amount of slope. You know, some of the tubing projects that we've been on, you know, in the last, 12 months, you know, we've had as low as 7 or 8 feet on a quarter mile of elevation change. So it really does pose some challenges when we're installing a new tubing system in that particular situation, or if we have an existing system in that woodlot with that, shallow a slope. Maintenance becomes even more important, because we do not have that slope to make up for imperfections in our system. So when we look at, the tubing in the Midwest, we have a tremendous amount of tubing that is put in at 0.75% of slope up to a 1.5% of slope. Of course, we get down in the southwest corner of the state and some of the western side of the states, we have some very nice slope. We have some nice, elevation change. Don't get me wrong, the more slope, the better for a tubing system, but we still can, come up with very, very good yields on woodlots that have a very limited amount of slope. If you have a woodlot with shallow slope, the tubing maintenance is even more important than normal, for lack of better terminology. We really need to make sure that we have that system, set to grade, supported properly, so that we are seeing, the good results or the good yields out of that tubing system. The first step of the process really is your main lines are really the backbone of your tubing system. If we don't have that part of it right, we can have 3 taps on a 5/16 line on a high vacuum tubing system and really be chasing down yield. But if we don't have our main lines right, if we're not transmitting a vacuum properly through that system, and getting tap back to that 5/16 line and out to that tap hole, we really miss the yield. So main lines should be straight and tight. Like I say, we want to make sure that these lines are maintained properly. So when we look at a lot of our main lines, here in the Midwest, this is what 0.8% of slope will look like on a 4-foot level. It's not a lot. One thing I will say, when you do buy a level to use in the woods, if you are on a shallow slope woods or own a shallow slope woods, buy a good quality level, a 4-footer or a 6-footer, especially if you're on very, very flat woodlots, is definitely a nice tool to have in the toolbox when it comes to checking main lines. The other nice thing to have is a set of these brackets. These brackets are available I know they're available through CDL, possibly a few of the other maple retailers. They clamp onto a standard level. You simply hang the level onto the main line, and then you can read the grade on that particular level. Like I say, very handy to have, especially if we are in some very shallow slope woods.
Hey, Jim, I want to cut in a second. Can you make your volume a little bit louder? People are having a hard time hearing you.
Okay, hold on.
Thank you.
We're going to try something different here. Can you guys hear me now? Hopefully it's a little better. So I guess no response is a good response, I guess, at that stage of the game. So hopefully
yes,
you guys
much
can hear
better.
me.
Thank you.
Okay, there we go. All right. So, all righty, we'll just close out of that menu and get my PowerPoint presentation to come back here, hopefully. There we go. Okay. So there are 2 different ways that we can look at, installing main lines into a woodlot. We see a lot of main line on like the picture in the left that is side tied and is tension between trees, or in this case where there was an absence of trees getting to a pump house and utility poles. Side tying the lines does add extra tension, does keep them tight, keep them sag free. We are seeing a lot more tubing installations happen like the photo on the right side, which is a straight line run or straight runs, or as straight as they could possibly be, supporting in between long spans with posts. Like say we want to keep that main line, like say, tight and wrinkle free. So with that being said, we can use posts in a lot of applications to support the main lines. Cedar posts work pretty well. In most cases, we do not put the posts into the ground. We set them simply on the soil surface, tamp them down, so that they're on good firm soil prior to putting them onto the main line. And then once we do get that post put in place, what we do is we'll take a little piece of hardware strap, make a U shape, and then we'll simply just screw them on to the cedar post. We like to use a fairly short screw here. If you can use like a 3/4 inch or a 1 inch, something that doesn't have a very coarse thread. And the reason being is if I get a tree that falls across there, I simply want to pull that screw out of that cedar post versus breaking my main line. So this is a good way to take some of the sags and low spots out of your tubing system. We also want you to put a wire tie on each side of the post. By putting that wire tie on each side of the post, that prevents that post from wanting to tip to the left or right. So this is a quick, relatively inexpensive way of putting support into that tubing system where it has a relatively long span. One thing that we like to shy away from, especially if you are in a very, very flat woods, is we like to stay away from the steel posts if we possibly can. The steel posts have a tendency to conduct the cold, and we do see a little bit of heaving on those posts throughout the winter months as that cold basically wicks down that metal post and freezes the ground around it. We have a tendency for that post to heave just a little bit. this is not very critical. If you have a woods that has 2, 3, 4% slope, just, screaming down a hillside with all kinds of slope, not a problem to use the posts, because if we have a slight heave, we're not going to notice it. But like we had noticed in that level, on that picture of that level before, when we're working in slope that the bubble just barely touches the line, any amount of heave that we can have in a system, a 1/2 inch to 1 inch, can create a flat spot or a high spot in our system. So we need to be very careful on what we're using for posts and how we're posting out in the woods. So main lines, and I will say this, as a woods consultant and as a tubing consultant, I spend a lot of time in the woods. I have a phone in my pocket, it's got a camera. I do run across all kinds of interesting things, which you are going to see some pictures of today. Black tape or electrical tape is not a good repair device for a main line that has a bear bite on the bottom side, where the teeth have pierced through the bottom side. Eventually the electrical tape will give way. And as long as we're talking about electrical tape is not a good solution for a 5/16 line fix. I do see a tremendous amount of electrical tape in the woods. Like say stainless steel splices to repair that main line, a 5/16 line splice for the tubing connections to make sure we have a nice solid repair, that we're not going to lose any liquid or lose any vacuum. So like say we see a little bit of everything out in the woods. If you have some road crossings, we like to stay away from the cam lock style fittings. Cam lock style fitting is simply a flat faced gasket in a flat faced nylon piece that are just coming together as a butt connection. And we really don't see a very positive lock on a lot of those devices. So if you do have some road crossings that have some of those older style, banjo type connectors or cam lock type connectors, a really good replacement for that to ensure a leak-free system is a stainless steel connector with a silicone gasket, and the clamp that goes all the way around, just like the clamps that we're running on our evaporators are on a lot of our stainless maple equipment. Provides a nice solid connection that we don't have to worry about leaking, and then a very easy connection to take apart in the summer months, and easy to place a cap and a clamp back on, so we don't have any critters that are crawling into the inside of our tubing. And then, like say, another little device that works pretty good for the road crossings are these small load binders like this, to open up that line and to take that tension off, so that we can disconnect that line and we can yet pull it back together in the fall for closing off that road prior to syrup season starting. So when we look at main lines, like I mentioned before, we see all kinds of interesting stuff. When we're out in the woodlots, in the picture on the left shows a couple of main lines being attached on a single wire with some longer wire ties. We want to make sure that we're only securing one pipe to one wire while we're out in the woodlot. When we see piggybacking of pipes like this, we see a lot of dips, we see a lot of sags. We see a lot of lines getting snaky, and just not a very good way to install it. I know it saves a little time. I know it saves a little money on wire. I know sugar makers are relatively thrifty folks, but we get one chance to get this system, to function properly and well. Let's just make sure we're only hanging a single pipe on a wire. A picture in the center, as we're wire tying pipe in the woods, we want to make sure that we are maintaining our wire position on our pipe. So typically our wire position, the wire should be on the top of the pipe. Okay, you can see when this got wire tied, they were pulling in a corner as they were coming into a wet dry connection, and they wire tied that line fairly high, and that creates a high spot in the system for sap to get backed up behind it in an area to start freezing. So like I say, we really want to pay attention to that wire, and we really want to pay attention to not creating that high spot in that tubing system. Another common problem for first-time tubing installers is, they'll put the wire up through the woods, and we're going to talk about the photo on the far right now. They'll put the wire up through the woods, and as they're pulling the main line pipe into the woods, they'll actually cross over the top of the wire versus keeping the main line pipe underneath the wire. So as they are coming through the wood lot, tying that main line onto that wire, they will find a spot in there where the wire slowly makes its way all the way around the pipe, because the pipe is actually wrapped around the wire. You know, so this picture will come out of a wood lot. It was a really good example of, oops, I wrapped it over the top of the mainline wire, and when it was wire tied, it was wire tied right over the top. So, you know, with that being said, that was 1-inch diameter pipes, and all of a sudden we have a 1-inch high spot in our tubing system. Happens more than you would think out in the woodlot. I see this quite often. So like say, just keep an eye when you're installing your tubing. And if you have a spot of that you did this in your woodlot, you can simply cut it, get the, you know, twist the pipe back around, get everything back on the bottom side of the wire, and put a stainless steel splice in to take that spot out. It's not the end of the world. It is repairable, so it is something that can be easily fixed. So. So when we talk about main lines, like I mentioned before, we want to make sure that we're using tension grips. Tension grips are there to pull the pipe snug. As plastic piping goes through temperature changes, warm to cold, we have the tendency for that pipe to shrink and expand. We really want to pull that tight pipe snug so that we don't see these wrinkles in our main line. When you're using tension grips, this is an example of a tension grip here in a woodlot that was not secured with a hose clamp around the tension grip. And you can see the picture in the left shows the tension grip on the pipe. The picture on the right, I can simply grab that tension grip and slide it on that pipe. And what that'll do is that'll release that tension that should be pulling on that tubing. So we want to make sure if we're using tension grips, we do get them secured onto that pipe with a hose clamp. Okay, so when we talk about securing pipe with a tension grip, so the picture on the left is an example of a main line. The wire ties are 10 feet apart. This particular line was put up. It was loose tied every 10 feet. Tension grip was installed. We pulled the pipe tight prior to wire tying. So you can see how nice and straight that pipe is. When we finish wire tying that particular pipe, it will remain nice and straight without all the sags and buckles and wrinkles, you know, whether the temperature is warm or cold. And really that's what we want in our system. We want to make sure those lines are nice and tight and really wrinkle free. So when we look at the picture on the right, we have a little different scenario. This particular line did not have a tension grip. You can see it's final wire tied about every 12 inches. And you can see how snaky and saggy everything gets. You look just a little bit closer, you know, you can see here where the wire is actually hanging up in this area, and the pipe has buckled below that particular main line. So this is what we start to see when we have lines that aren't really properly secured prior to wire tying. So we're going to talk a little bit about, you know, the purpose of the main lines, what's really going on, you know, inside of these lines. So when we look at this first line, it's kind of hard to tell. But you can kind of see, we used a clear tube for this example. You can see the liquid level in this tube is just about below the halfway point of that particular line. So when we look at that, you know, this is really what we want to see in our main lines. We want to see that liquid level, you know, consuming, you know, half or less of the pipe, especially on a line that is focusing as a wet line that is taking, you know, sap into a releaser and transferring, you know, transferring vacuum back to our taps. So when we look at this, we have a nice open air space on top to transmit vacuum. So our surface of that liquid work its way back so that we have good vacuum on our lines that are coming off our main lines. So we need that nice open air space to transmit vacuum through that vacuum line. And, you know, just keep in mind that we can't pull vacuum through liquid. So what we have to do is we have to pull the liquid out of a sag or a dip, like you're going to see here in the next photo. You know, when we have that sag or that dip, you know, we really cut off the vacuum. The other thing that it does is we increase the surface area that our liquid is coming in contact with, which then increases our friction to our liquid running down our line, which then slows our sap down, and it will heat our sap up eventually. and cause us to make a lesser quality sap or syrup. The other thing with these particular ones is, like I mentioned, we have no space for the vacuum to travel. And then we have a sag, you know, and if we go through an evening and we go below freezing, we freeze that line solid. And until that line thaws the next day, we can't get vacuum past that section that has the sag. We also back up the sap and everything behind it. So not only are we not getting vacuum back to our taps, you know, we are backing up the sap and we can't get the sap out of the system, which in turn pressures everything right back to the tap hole. So looking at the pictures one more time, you know, that nice tight sag-free line, you know, allows sap to exit that tubing system really quickly. You know, and that's one thing that we've really learned over the last number of years is the quicker that we can get the sap out of the tubing system without heating it up, the better quality syrup we will make. You know, it's not as critical early on in the season, but as the season progresses, our equipment gets dirtier, the microbial contamination gets higher, our ambient air temperatures increase, we grow that microbial contamination that much faster when the temperatures get warm, and that's where we start to see some problems with quality arise. You know, we have some tubing systems. We have the sap coming into some tubing systems that aren't necessarily stellar. They got some dips and sags. They get into these dips and sags, and say, for example, that is a black main line on a 60-degree sunny day, late season. Well, that sap in that sag is heating up to the point where it's 70, 80 degrees before it's pushing out of there. You know, and that's really what we don't want to see if we're trying to maintain some quality. The other thing is these particular pockety areas like this in the off season, like right here, if the sap isn't draining out of those, you know, we grow a tremendous amount of microbial contamination in those sags. It never really flows out of that sag. So we've got fresh running sap down that tubing system, and it comes into this saggy spot of the main line. And we really can foul up a lot of fresh run sap by having that older contaminated sap in that tubing system. Okay, so like I had mentioned, I'm the guy in the woods with a camera all the time. If you are using some lighter colored main line, you know, as you're walking through your woodlots, it's really easy to see, you know, problems developing in the system. You know, you look at this red circle here, you can start to see that green discoloration of all that really good stuff growing inside of your tubing system with that sag. So this picture was snapped in a woodlot in about July, full of sap yet, big sag in the system. And we, like I say, we grow a lot of interesting green and black material in these sags in the off season. You can see the picture on the right, same scenario as well. You know, we see a lot of sap sitting in that sag there. We grew a lot of contamination in that pipe. And you can see in this area right on the other side of this tie-off tree, we got another sag right here, and you can see that discoloration in that pipe. So that translucent tubing, you know, really is a kind of a useful tool in the woodlot. You know, every woodlot has a specific, you know, tubing put into it. You know, if you got a woods that's shaded with some hemlock or some spruce, you know, we'll see some black pipe in those woods to get that line to thaw quicker. You know, if we've got some north slopes, we'll use some black pipe there a lot of times to get those lines to thaw a little quicker. But if you walk up and if you're using some of these translucent blue main lines, the nice thing is you can actually see the sap in these lines. So when I walk through the woodlot, you can walk up to that pipe and you can see exactly where that liquid is in that line. Same thing is happening during sap season. You know, as you're traveling through that woods, as you're walking lines, checking for leaks, you get to a spot, hey, I got a dip right here. You know, I need, you know, I can see the liquid level in that line. You know, if you can't fix it right away, you know, throw a roll of marking tape in your tool belt or in your apron and mark that spot and make sure that you can get back in there and get that egg taken out of there, you know, and get it tightened back up so that we don't have that issue. So when we look at Sap Flow, if you're using a high vacuum system with a releaser, or even if it's a gravity system, you know, you can look at this system and you can tell, you know, how a good functioning system is going to work here. I got a short embedded video here. Hopefully I can, well, get her to play for you. maybe. Well, all kinds of interesting stuff happening here today. There we go. All right, we're back. So if you look at that stream of sap coming into that releaser, it should be a nice steady stream. Okay, it look like a stream of sap that is really, you know, running out of a garden hose. Just a nice steady stream. Really no interruptions, no splashes. So when we look at the next releaser, you can see the lines on the inside. Whoops, there are. We are seeing some lines that quit running and then they start running. The line nearest to the side of the releaser had a very slow flow, and then it got a lot stronger. And you look at the variation of flows internally on that releaser as that sap is running in there. We know we have some issues on those lines because what's going on is we're actually pulling the sap out of those low spots and slugging it into our releaser. So like say, we should see a nice steady stream coming into our releaser under vacuum. If we're seeing slugs and sprays, you know, we know we've got some problems with some main lines out in the woods. So if you have an older tubing system, or depending on when you put your tubing system in originally, one thing you can do is you can, you know, change out some plastic fittings and go into the stainless steel fittings. The non-restricting mainline fittings that are made out of stainless steel are a very nice tool. So when we look at the plastic fitting versus the stainless fitting, most of the stainless fittings have a 1-inch inside diameter for this particular piece that goes into a 1-inch tube. So the splices that you put in are the same diameter of your tubing, so that we don't have any problems with ice backing up behind the fittings or creating any bridges or dams behind any of the fittings. Now, you really need to watch what stainless fittings that you're buying. Not every manufacturer is selling full port fittings, you know, so take a tape measure in your pocket, measure the fittings, know what you're buying. Some of them are undersized, 1 to 8 in installation, and 2, they're a little cheap to make. So like I say, just kind of watch what you're buying for fittings, and like I say, try to use that non-restricting fitting. It not only, you know, gives you problems as far as, you know, ice backing up and everything behind it, but we also look at, you know, vacuum flow. So say, for example, I put up an inch and a half vacuum line, and I use a poly fitting, which reduces my inside diameter to 1.25 inches. So we look at friction loss, and we look at the narrowest spot in the pipe, which would be that 1.5 inch connector, that plastic connector that has an inside diameter of 1.25 inches. So if I put a 60 CFM vacuum pump on a 600-foot line with an 1.25 inch inside diameter, or an 1.25 inch splice that's poly that has an inside diameter of 1.25 inches, I'm only going to get about 16 CFM at the 600-foot mark. So if I take that same chart and I've got an 1.5 inch vacuum line with a non-restricting stainless steel coupler in it, you'll notice the same pump at the same distance, I can put 25 CFM to the 600-foot mark in that system. So we really see a big reduction by using that poly fitting in a vacuum line from an 1.25 inch inside diameter to a 1.5 inch inside diameter on a 60 CFM pump. We see like about a 36% reduction just by having that 1/4 inch smaller fitting based on the friction loss that we see. So kind of keep that in mind. You know, a lot of times people will put up a vacuum line, it doesn't matter, we're going to put poly fittings in this one, it's just a vacuum line anyways. Well, we need to make sure that we transmit vacuum to that releaser or whatever the case may be, so we don't want to have any line loss there if we can possibly, you know, help it. So main lines. So when we talk about stainless steel fittings, a lot of times what we do is we heat the main lines to put the fittings in. Excessive heating of a main line is a bad thing. You'll notice on the photo on the left, you know, if you have fittings in your wood lot that you've heated just a little bit too much and we start to see a thin spot develop, we're going to have a failure right in this area. Okay, so just keep in mind if you're warming pipes to put them on, we don't want to warm them too much. Another product of warming main lines too much is we'll have a tendency to get the whole pipe warm. We'll put a kink in the system, And this kink is like say it's reducing our liquid flow, it's reducing our vacuum transmission. So we really got to watch for stuff like that as well. Here's the example of that poly fitting in that dry line or vacuum line. One thing that we always strive to do is we want to make sure that we are putting double hose clamps like you see in this picture here. One thing that we've learned over the years with vacuum, what doesn't leak at 21 inches of vacuum will leak at 22 inches of vacuum. And the higher we go, it gets worse. What doesn't leak at 27 inches of vacuum will leak at 27 and a half. And really what we've done over the years is we've really encouraged everybody. In fact, all the tubing projects that we quote, we double clamp everything, even on the stainless fittings. We really want to make sure that we have a nice solid connection on those fittings that is leak free. So like say, just if you got an older system and these weren't put on with a like a little 12 volt or a 18 volt electric impact, they were just put on with a nut driver, there's a good possibility they're very loose. Check your clamp, check the tension on your clamps, double clamp them, try and seal that system up as tight as we can get it. Okay, so we're going to talk a little bit about lateral lines now on a traditional 5/16 tubing system. So we really want to try and keep our lines under 100 feet in length on the 5/16 tubing systems. As Tim Perkins mentioned this morning, 5 taps or less on that 5/16 line is really kind of the key. We really want to keep those lines as tight and as sag free as we possibly can. We do need to keep the lines to grade. Remember, gravity moves sap. Okay. So once we get our 5/16 lines up, we want to make sure we do get them set to grade. Okay. Maintain lines with proper tubing repair parts. Like I had mentioned before, leave the black tape or the electrical tape in the electrical toolbox, and let's use some maple fittings to repair that main line in that 5/16 tubing. Monitor contamination levels in the tubing system. If we have certain spots where we're seeing that microbial contamination level, elevated, replace sections of 5/16 tubing, replace drop lines that are showing that heavy microbial contamination. Like say, and manage drop lines for contamination and for length, so that we're making sure that we're tapping that whole diameter of the tree, that tapping band. We want to make sure we can access it all. So we look at lateral lines. Lateral lines, like I said, should be at least 100 feet long. They should be set to grade. We should see a nice downhill slope on those lines, if at all possible. Once we get them set to grade, and for those of you that know me, or if you've been out on a woods walk with me, you will know that I am a very picky person in the woods. We can have the nicest sugar house and the shiniest evaporator, but if we're not getting it out of the woods, we're not going to make any syrup. So one thing it's a real quick, simple fix is if you can get some 7-year marking paint. Once you get your lines set to grade in the woods, you can just take some of that marking paint and you can simply just put a dot of paint on the tree where the 5/16 line crosses the tree. You'll see that on the picture on the left. Picture on the right, if you get a limb or something that falls over the line in the middle of winter and you're out there tapping and okay, where does this line go? Simply pull it up, put it back on its paint mark. Your 5/16 line is back on grade and we don't have a sag or anything in it. So it's just one of those things that you can do right quickly to ensure that we're keeping that 5/16 line set to grade out in the woods. Drop lines should be stored on the pinner cup in the off season. Drop lines should be replaced every 3 to 4 years. And this is really gonna, depending on the type and style of yield that you're looking for, 3 to 4 year mark, probably from a cash flow point of view, and a yield point of view is where we should be replacing those drop lines. Pictures over on the right, if we see this heavy microbial contamination in 5/16 line, or if we see this kind of contamination in drop lines, they should be replaced regardless of age. Even if that drop line is only a year or two old and we have a really extreme amount of microbial contamination like this, from having sap left in it throughout the summer months, whatever the case may be, we should make sure that we are pulling that out and getting that contaminated line out of the system. Lateral lines, we always recommend drop lines should be a minimum of 36 inches in length, because we want to cover that full diameter of that tree. On a 2-tap tree, we want to make sure that we can at least reach around half of that tree and we can work that tapping band of that tree without without running out of pipe. So if you've got an older tubing system, that was put in a number of years ago, and you've got 18 or 24-inch drop lines or short drop lines, and you can't reach any white wood anymore, it's a good recommendation to replace that drop line and get, if you had that small short hose on there, get that longer hose on, like a 36 or possibly a 42-inch, get up over the top of that tapping band where you were limited to what you could reach, and get that tap set into some nice white wood. This also plays in mind, kind of another little tip when it comes to replacing tubing in a wood lot. If you're replacing some tubing, try to run that 5/16 line on the opposite side of the trees as you're zigzagging through the woods. That if we had a tap tree with a short drop line and we weren't able to reach around the whole diameter of that tree, run that 5/16 line, on the opposite side of the tree in that tubing replacement process to make sure that we're getting that tap into kind of a fresh zone or some fresh wood on that tree. So like I say, managing length of drop line is really important. We want to make sure that we're always setting that tap into nice white wood so we get our best yield. Lateral lines should be as sag-free as possible. Try to avoid long spans. I know not every woodlot is perfect, and I will say, this is one of my woods right here. We've got an awful long span where we have nothing in between. Most of our ironwood has tipped over and died, and we don't have a lot of options. So we'll, try to avoid situations like this. I know they're not always avoidable, but like I say, try to avoid them if possible. We want to try and keep them tight and sag free if we possibly can. So, okay, so when we look at lateral lines and we want to make sure they're free of leaks, this is really one of the keys, especially when you start to, to use, high vacuum, and it's really no different for if you're using a 3/16 and creating a natural vacuum. We need to keep that system leak free. This is a really good indication of a 5/16 line with a small rodent shoe on the backside. And you can see the day this photo was taken, it was about 38 degrees. It was overcast and cloudy. We were getting a really decent round of sap that day, but that high velocity incoming air leak, even at 38 degrees, will freeze lines completely solid. So you can look when I start the video here, you can see that small squirrel chew right about in the center, and you'll see the air rushing in and how it froze that line solid. So anything after that ice in that line is sap that we're not going to get. So if that's the first tree in the line and there's 4 taps behind it being froze solid, we're really not going to get anything out of that line. So it really is important to even watch those small little nicks and micro leaks in the system that you don't think are necessarily leaking. Here's another example, and this isn't the most clearest video that I have, but this is an older style fitting that is not the no mold seam to prevent the micro leak. So if you can see, you can just barely see my pliers on the tubing on the left hand side of the video picture there. I've got the line blocked off, and when I start the video, bubbles that are transmitting up the line, and basically that leak is the leak on the mold seams on that particular splice connector. So the day that I took this video, my system was running right around 28 inches of vacuum, and at 28 inches of vacuum, that mold seam on there created enough of a leak that I could get those bubbles to come right up that 5/16 line. So that's how critical, the higher we go on vacuum, how critical it is to have good fittings in the system and to have that system be leak free. Here's another good indication. We got, like say, a fairly good leak on that line. You can see the liquid coming through it. So like say, we just want to make sure that we have that system as leak free as we possibly can. This is another good example. So this is a picture that was taken in one of our woodlots. We had a 5/16 tap line come off a tap. We had a limb go over a line, and it took the 5/16 line off a tap. So when that line came off the tap, the high velocity incoming air at about 28 inches of vacuum will freeze your main lines completely solid. You can see the frost and the ice built up there. That high velocity incoming air, grew a bunch of frost on there until I eventually froze that main line completely solid. like I say, once again, when that happens, everything behind it is completely frozen, and we really can't get any vacuum or liquid past that chunk of ice in the system until it thaws. So a little bit, we're going to touch briefly on tubing cleaning and sanitation. I will say that, the replacement options in my mind are probably a better option than cleaning. It seems like when we do some flushing with water, we really don't lower our, I shouldn't say we don't lower our microbial contamination or our microbial load. We lower it for a small period of time, in the spring right after we wash the tubing. And then, as the months progress on, by fall, we start to see that microbial load grow right back to where it was. And I'm not going to talk a lot on sanitation. We're going to talk a little bit about it. You can find these studies on mapleresearch.org. This is a summary of the 2013-2014 studies that Cornell and Proctor did. And they look at different treatments such as cleaning compared to a new spout, cleaning plus a new spout or a new drop line. So you can see the changes in the yields, and that's where they're really seeing that 3 and 4 year drop line replacement, new tap every year. That really does, show a difference in that yield. Years ago, we used a product, we used several sanitizers in our sugar bush throughout the years. One of them was bleach. That was not a good program or any bleach-based, substance. When that sodium and that bleach, salts out and gets all over that tubing system, it's just like blue licorice. Every animal in the countryside wanted to come and eat on it. So there is some food grade hydrogen peroxide that you can use. It is a premium food grade hydrogen peroxide that does give a little bit of result as far as that goes. But really the biggest thing that we can look at is new drop line, and definitely, managing the contamination in that drop line and spout replacement on an annual basis. And so with that being said, also, leave that vacuum on. You can leave that vacuum pump run. I know CDL makes some instrumentation that works along with their monitoring system, that when flow rates and vacuum start to flow down or slow down at night, we actually modulate that vacuum. We'll leave the vacuum pump on, run the vacuum in the system at a lower level overnight. It'll help the system not freeze as solid. It'll help it thaw more rapidly in the morning. And we're not having the opportunity for any of that sap to make its way back to that tap hole to start that compartmentalization process. So let's say some different things that you can do there, other than the sanitation. So I'm going to touch on isopropyl alcohol. As an equipment consultant, I travel the Midwest. I get into an awful lot of woodlots. And, when I pull into a woodlot in the middle of January and the truck thermometer says 0, and I get in there 100 yards and I see a big sag in a main line and the liquid flows pretty easily, well, you can kind of guess what's in that system. That's probably some isopropyl alcohol. We have seen a lot of isopropyl alcohol being used here in the Midwest over the last number of years. I took this quote directly out of the 2016 issue of the February Maple Digest. Isopropyl alcohol is a prohibited substance. It is not labeled for use in our tubing systems. So with that being said, also to take it one step further, it is hard in the Midwest to find food grade isopropyl alcohol. So I'm under the assumption that a lot of this isopropyl alcohol that's being used in some of these systems is not food grade. So in that case, it's like taking a can of heat and dumping it into your, instead of your gas tank, you're dumping it into your tubing system. So kind of keep that in mind. Like I say, it is not approved. And, with it being said, any syrup produced with IPA in a system could be seized and destroyed, because it's got a pesticide material, as is labeled as a pesticide material into the system. So like I say, keep that in mind. We do see a lot of it being used here in the Midwest. So any questions, I guess, at this time?
Sorry, Jim, we were napping.
No, that's all right.
We do have a couple of questions. The first one that came up was, how do you size your main line for the number of taps? How big should it be for how many taps?
Well, that's a product of a lot of different calculations, actually. So one thing we need to do is we need to look at the density of the woodlot, okay? Because typically we like to space our main lines around 100 feet apart. And so with that being said, we need to look at the slope in the woodlot to determine the size of the main line. We need to look at our taps per acre, and we need to look at the distance or the run of our main line. So I mean, I can't give you a cut and dried answer as far as for how many taps should be on that specific size of main line. It's a little bit determined by the conditions in your woods. Like say slope plays into it, taps per acre plays into it, the number of taps on that specific run. So say for example, I have a woods that is 90 taps per acre. I have a main line run that is going to be 1,000 feet long, and I know my spacing is going to be 100 feet apart. You know, what we do is we sit down, we calculate, you know, we look at the density, we look at how many taps per acre, we look at how many acres are going to be covered by that specific main line, and we make sure that we size it accordingly to match the volume of trees that are out there. So not necessarily all the time is it a 1-inch main line. It could be an 1.25-inch main line if we have a lot of, you know, density in that particular wood. So there is a little bit of calculation that goes along with it. So.
Good, thank you. The next question is, what's the best technique for replacing drop lines? How do you remove the old drop line without damaging the tee?
So when we talk about drop line replacement, we should be replacing the tee and drop line altogether. You know, if you go at any of the fittings with a utility knife, you're going to score them and you're going to cause a score through the barb and you're going to cause a vacuum leak. You know, so that score in that fitting is very similar to the video I showed you of the splice or the connector there with the mold seam that's exposed that isn't machined off on the end for no micro leaks. You know, we score that hose barb, and basically at that stage of the game we have a leak. So the best thing you can do is drop line and tee at the same time. You know, don't try to cut anything apart and try to replace it that way. There are some disconnect fittings that are also available out there. If you're going to be in the area of drop line replacement, there are some quick connect fittings that you can buy buy that set, and you can disconnect that drop line and take it off. So.
Thank you, Jim. The next question is about cleaning. Fall cleaning versus cleaning the tubing in the spring after the season. You know, do you do both? What do you recommend there?
Well, anytime that we can clean the tubing close. So, you know, if you look at the tubing studies, you know, and like say, I'm not a researcher from University of Vermont, but if you look at their tubing studies, you know, any of the tubing treatments that were taking place right after season, what they did is they looked at the microbial load by fall. So like say if the treatment was made in say May, for example, for the tubing cleaning, they looked back and they looked ahead, or they looked back, however you want to look at it. And they looked at the microbial load that was in that tubing system in September. And so the closer that we can clean that tubing prior to the production season, the lower our microbial load should be.
All right, thank you. The next question. So even small leaks on a lateral line should be fixed with a plastic connector instead of using electrical tape. I think they're asking you to confirm that.
Yes, yeah. Anytime that we can, you know, so it may be a quick fix, the electrical tape for that first couple days, but you know, as the sun beats down on that black electrical tape and the ambient air temperature gets about 65 degrees, that tape gets kind of gooey and it wants to kind of expand, and then it doesn't quite contract, and it's going to end up leaking anyway. So I mean, the connector or the repair splice is definitely the mode of choice as far as repairing that tubing on that lateral line.
Thank you. Well, the last question here looks like a repeat about the cleaning question. I'm talking about a two-step system for cleaning. I don't know if you've got anything to add on that. Otherwise, we'll thank you for your time. Yeah,
I guess I'm not really sure about the two-step cleaning. I see another thing popped up here. So what about alcohol for cleaning? Alcohol is not labeled. I don't care what kind it is. It's not labeled for use in the tubing system.
Perfect. Thank you, Jim. Yeah, and Dr. Perkins stressed that too, that alcohol is not legal to use in the United States to clean your tubing. Anybody that's doing it could get into some pretty big, serious trouble about it. So stop.